compound interest formula is used to find compound interest in the amount that is in an account after a certain period of time, or the amount that would be owed back after a certain period of time. Now, this is assuming that you're not making payments or investing any more money into the account. So the compound interest formula is actually based upon the formula you got from part 1. It's very similar to it. It is the total amount is equal to P, which stands for the principal. That's the amount invested or the amount owed, times the quantity of 1 plus, and then it says R over N. So we already know that R is the rate, and that is always written as a decimal. N is a new variable. N stands for the number of times compounded per year. So you see the N is a part of the variable, and then T stands for time, and time is almost always in years. So let's look at example number 3, which is an investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in the account, what will be the balance after 15 years? So we use that formula. A equals the principal, 1 plus the rate over the number of times per year to the NT power. And that's an R for rate there. So the principal is $2,500. That's the amount that was invested, times 1 plus the rate is 4.2% as a decimal. That is 0.042. Over N for the number of times a year. N is, let's see, that is monthly. It says monthly in the problem, so that is 12 times per year to the 12 times, and then it says for 15 years, so T is 15, and that is the substitution step. It's going to be pretty difficult to do this without a calculator, so think about how you would do order of operations, and we would do parentheses first, and inside parentheses we have a division part, so we would take 0.042 divided by 12. You would do that first, so we'd have 2,500, 1 plus 0.042 divided by 12 is 0.0035 to the 12 times 15 power. And then that would be 1 plus 0.0035 would be 1.035. And 12 times 15, I'll go ahead and do that. That is going to be to the 180th power, which means this is almost impossible to do without a calculator. So when you have your calculator, you would do the exponents next and then take that answer times 2,500. So when you take 1.0035 to the 180th power on a scientific calculator, you get about 1.875546, et cetera, et cetera, et cetera. Go and just leave that in the calculator because you only have one final step, which is to multiply that times 2,500. And you get $4,688, and if we round to the nearest cent, that would be about $4,688.87. And then the last problem actually kind of goes back to 6.1 or 6.2 part 1, which is solving an exponential inequality. You do that very similar as with an equation. We're going to try to get both of the bases the same. So 16 and 8, they are both powers of 2. So I could rewrite the 16 as 2 to the 4th power, but that exponent already had a 2x minus 3 in it. And then that's going to be less than 8, which could be rewritten as 2 to the 3rd power. And the 8 didn't have any exponent with it, so there was no other exponent to bring down. So since the bases are the same, that means the exponents must be set less than to each other using the same symbol there. So it would be 4 times the quantity of 2x minus 3 less than just the 3. And remember, we don't think about this as the 2's canceling each other out. It's just if the bases are a true inequality, then the exponents must have the same true inequality. And then we solve this just like you would with an Algebra 1 question. So it would be 4 times 2x is 8x. 4 times negative 3 is negative 12. That's going to be less than 3. And then we will add 12 to both sides. So 8x is less than 15, and then divide by 8. And 15/8 is good enough for the answer, so x is less than 15/8.